Why, hello, how's it going? Today we're going to look at additive numerical patterns. So first off, let's break down the phrase additive numerical patterns. Remember we talked about additive rules earlier this year when we were talking about adding to like our x, like for instance, x plus 4 equals y. That would be an additive um, an additive rule because we are adding. There are also multiplicative rules, so like 4x equals y. So like 4 times x equals y, that would be a multiplicative rule because you're multiplying to get your y. Right, so for instance, if you saw like x plus 4 equals 5, then you would know that, let's review how we figure that out. What plus 4 equals 5? 1 plus 4 equals 5, so x is equal to 1. Over here, let's say 4x is equal to 12. 4 times something is equal to 12. What times 4 equals 12? 3. So x is equal to 3. All right, so here is an additive property, and here is a multiplicative property. One of those big words. So we're going to be looking at additive today because before, when we looked at additive properties, we were using strip diagrams to illustrate them. Today, we're going to use a graph to illustrate our data. So it's a brand new way of looking at data. We kind of started last week, and we will finish today, or we'll finish additive today. All right, so if we go and look at our objectives up here, our objectives are describe the key attributes of the coordinate plane and graphing in the first quadrant of the coordinate plane. So your x-axis is your horizontal axis, your y-axis is your vertical axis, and then the place where you start is the origin, and that is 0.00. It has an x of 0 and a y of 0. So those are your key attributes, and then you can graph in the first quadrant. We've done that. We'll do that again today. I can generate a numerical pattern when given a rule. That's what we're going to work on today. Generating a numerical pattern when given a rule is drawing on the graph with the data. So, and then we will recognize an additive pattern today. All right. So, let's clear the screen and let's move on. Okay, so here is some data. All right. So, pretend you're in science and pretend like you have a long 3-year science class. So you're looking at a plant, all right, and we're looking at the data for the plant. So it looks like when the plant was just planted, when the plant was just planted, it was 4 inches tall, all right. So new plant, 4 inches tall. After 1 year, it was 5 inches tall. After 2 years, 6 inches tall. After 3 years, 7 inches tall. So with this, we can probably sense a pattern of how much this plant grows per year. It might be easy to see right now, or you might be thinking like, I need more data, or I need to organize my data to find out how much this plant grows per year. So first off, think to yourself, can you see what the pattern is? How much does the plant grow each year? All right, so it looks like it grows about an inch a year. So let's take a look. Okay, so let's examine more closely. Here's our plant. It's 4 inches, it's 5 inches, it's 6 inches, it's 7 inches. This was after 1 year, 2 years, 3 years, 4 years, or just planted 1 year, 2 year, 3 years. All right, so here's what they're gonna do. They're gonna make this graph. It's a table. And right here we have the number of years that the plant has been in existence. And then right here we're going to record the plant height. So go ahead and see if you can plug in the information here to the chart right here. And if we can organize our data a little bit better. So it should say how tall it was after 0 years, 1 year, 2 years, and 3 years. And I'll see you in the next video.